In this video, we're going to do an introduction to the idea of elasticities. And normally when people teach about elasticities, they'll start by calculating a lot of elasticities, and then they'll talk about how to interpret them. And I'm going to go backwards here. So what we're going to do is we're going to talk about a lot of examples of real-world elasticities so that you can really get a good idea of what they mean. And then in the next video, we're going to focus on calculating them from various numbers. So what an elasticity means, what it is when we're talking about an elasticity, we're talking about the idea of responsiveness. So every time you hear the word elasticity, think responsiveness. And here's what we mean by responsiveness. Imagine we're doing some kind of experiment. Elasticities always have to do with cause and effect. So an elasticity is the idea that you change one thing, that's the cause, and then you want to measure how responsive something else is to that change. So that's the effect. So cause and effect. And the way we want to think about elasticities is when we're looking at a number that's already been calculated, somebody tells you the elasticity in a particular situation, we always want to think about the cause as being a 1% change. A 1% change in whatever the cause thing is. And what the elasticity is going to tell us is how large is the effect, how responsive is the other thing to a 1% change in the cause, all right? So just try to keep that in the back of your mind when we're talking about this. Today is all about interpretation. And for each 1% change in the cause, there's going to be and then we're going to have this number called an elasticity. And that elasticity is going to tell us the percent change we would predict in the other thing, the effect, the thing we're looking that would change from this cause. So any elasticity, and this is going to be true when we talk about calculating elasticities as well, any elasticity, when we go to look at the formula for an elasticity, which we're not going to focus on too much today, but the formula is always a percentage change in one thing in the numerator of a formula divided by the percent change in something else in the denominator of a fraction. And we always call the thing on the bottom, let's think about that as being the A, right? A is the thing that's the cause. So A is the thing that's the cause, and the B is the thing that's the effect. So the cause goes on the bottom, and we're talking about a 1% change in the cause. There's a certain responsiveness or a certain percent change in the effect, okay? So anytime we see an elasticity, like when you read a standard chapter in a textbook on elasticity, the first elasticity that you're always introduced to is the Price Elasticity of Demand. And it's kind of cool. When you have the name of an elasticity, you also know the formula for that elasticity. We always name elasticities the same way. The first word there, the price, that's the cause. Right? So the first word in the elasticity there is the cause, and the second word is the effect that we're trying to measure. So price elasticity of demand, the price, the red, would go on the bottom down there of a fraction. That's the thing we're talking about doing a 1% change of. And demand, really quantity demanded, is the effect that we're trying to measure, okay? So when you're doing any elasticity, the first word is the cause, and that's the percent change that goes on the bottom of a fraction. The effect is the second word, and that always goes on the top of a fraction. Now, it turns out that's going to be really important to know when we go to interpret elasticities. Let's take an elasticity to start with, the price elasticity of demand for electricity. Now, depending on what data you collect, we get these elasticities by going out and watching people and how they behave. And we'll look at an area and we'll see that the price changed for electricity. And then we'll ask the question, how responsive were people to that price change in electricity? Maybe the price goes up. Well, the law of demand says that when the price goes up, the quantity demanded goes down. So we know people are going to use less electricity the question is how much less? How responsive are people to price when the price goes up or when the price goes down? It turns out that if you look at people's long-run reactions to price changes of electricity, by a long run, usually when we collect the data, we're talking about, say, a year or two after a significant change in the price of electricity. That's the number we're talking about here. The elasticity is -2. Now, that -2 was calculated, let's zoom in here, by observing some data. And in the numerator, we figured out what was the percent change in the quantity demanded of electricity. So that's what we mean here by this demand being the effect. Price of electricity doesn't really change demand. Remember, it changes the quantity demanded. But that's what we put on the top of the formula. And then the percent change in the price we observed goes on the bottom. And when we do that, we get the number -2. So what does that -2 mean? Let's start off with our standard easy interpretation. This is your go-to interpretation for elasticities in purple here. For each 1% change in the price, that's the cause, there will be a 2 or -2% change in the effect. Okay? So what we're seeing here is when the price goes up 1%, people use 2% less. When the price goes down 1%, this -2 says there's this inverse relationship. People do the opposite thing with the quantity as to what happens with price. Price goes up, quantity goes down. Price goes down, quantity goes up. That standard interpretation comes from this idea, that if we look at this as a fraction here, if we have a number like -2.0, and we know that's calculated as the percent change in the quantity people did for a certain percent change in price that they observed, then if we put 1% on the bottom, a 1% increase in price, then very simply the number that goes on the top has to be -2%. -2 over 1 gives us that -2. So this is where that standard interpretation comes from. For each 1% increase in the price, there will be a -2% change in the quantity of electricity that people buy. So that's one way to interpret it, but we're not limited to just 1% changes. A 1% change is always the easiest way. Just by knowing the elasticity, you can just say, hey, I know that because that's -2, for each 1% increase in the price of electricity, people will use 2% less. That's the -2. But we're not limited to just doing a 1% change in the price. What if there was a 10% change in the price? All we have to do is ask ourselves, what would go in the numerator of a fraction? What divided by 10 would give us -2? Well, 20 divided by 10 would give us -2. In fact, it's got to be -20, right? So -20% divided by 10% would give us -2. Since -2 is the elasticity, we know that whatever goes in the top divided by the bottom needs to give us -2. If we're talking about electricity, the elasticity is going to be pretty constant when we look at different places, right? This would say for a 10% change in the price, we would expect people would use 20% less if price was going up 10%, right? So the plus 10%, price is going up 10%, people are going to use 20% less electricity. Now, what would we predict if people were to cut the price, percent change in price down here, people cut the price of electricity by 10%? What divided by -10 would give us -2? Well, positive 20%, right? So positive 20% divided by -10% would give us that same -2. We're just looking at different things that give us a ratio of -2. So we'd predict if we cut the price of electricity, people use 20% more in the long run. If people raise the price of electricity by 10%, people will use 20% less in the long run. What if instead we were talking about only raising the price of electricity by 5%? What divided by plus 5 would give us that minus 2? Right, negative 10. Right, so what we're saying here is if we raise the price of electricity by 5%, we would predict people would use 10% less electricity. How about this last one? Instead of giving us the number in the bottom, I've suggested some number for the top. So the question we're asking here, and we could use algebra to do this, right? So we could do a little bit of algebra, and we could say, look, what we're saying here is that if 8% is the percent change in quantity demanded, maybe we want people to use 8% more electricity for some strange reason. Then what we're asking is, what is the percent change in the price that would have to go on the bottom in order to get people to use 8% more electricity? Now, if we want to think about doing this with algebra, we could just put x down there for that percent change in price and say 8 divided by x equals minus 2. What is x? Okay, we're just solving for x. Or we can just think, in a problem like this, it's kind of easy to think of a number, 8 divided by what equals 2? Well, it's 4%, of course. But again, it's got to be negative 4%, because if we want people to use more electricity, we're going to have to cut the price by 4%, and we get that ratio of minus 2. So this number minus 2, this elasticity, price elasticity of demand for electricity in the long run, not how people would react tomorrow, but how people would react a year from now or 2 years from now to a change in electricity prices. Minus 2 tells us, people are pretty responsive. What this minus 2 tells us is that no matter what the cause is on the bottom, no matter what the change in price is on the bottom, the reaction, the effect on the top is always twice as big. There's two things we want to look at when it comes to this minus 2. First of all, it's negative. That means that the cause and the effect are always moving in the opposite direction. Price up, quantity down. Price down, quantity up. And then we want to look at the magnitude of this thing, 2. The 2 tells us the effect is twice as big. The negative sign tells us in what direction it is relative to the cause. So it turns out price elasticity of demand is always negative or 0. We have not found, we've been looking for 200 years or more, and we have actually looked at records historically going back thousands of years, trying to find, has there ever been a product where we've raised the price of it goes up, ceteris paribus, right? Nothing else is changing, but the price goes up. And that causes people to want to buy more. We haven't found one yet. We haven't found a good example where we're convinced that that's happening. Now, price elasticity of demand, because it is always negative or 0, often, I don't like this practice, but I didn't invent it. Often we will drop the negative sign. Only for the price elasticity of demand. There are lots and lots of different elasticities, lots and lots of measurements of responsiveness between different things out there. Never drop the minus sign of any of them except price elasticity of demand. And I don't encourage it there, but the reason why I bring it up is it's common practice. So somebody might bring you a price elasticity of demand that they have calculated for the business that you're running. And they might tell you that it's 2, right? They just tell you, well, your good has an elasticity of 2. They might not include that minus sign like we were talking about here for elasticity. You have to know that really there's still a minus sign there. That any price elasticity of demand, when we're talking about the relationship between price and quantity, it's always that negative relationship where when one goes up, the other goes down. So economists have developed this lazy habit of dropping minus signs for price elasticity of demand sometimes. I don't like it, but you have to be aware of it, okay? Textbooks do it. Problems and question sets and homework sets do it all the time, so you have to be aware that this is common practice, but only for this elasticity. Every other elasticity, you always want to include the proper sign. Is it negative? Is it positive? Write it down. And I think it's good practice to do it for price elasticity of demand as well, okay? All right, so let's look at, now that we've kind of gotten our feet wet, let's look at a few other examples of elasticities. These elasticities come from many, many different sources, many different studies that have been done over the last 20 or 30 years, looking at different products and services. When the price goes up and the quantity goes down, how much, right? What's the relationship? And always looking at this relationship in a percent change compared to a percent change kind of relationship. So, price elasticity of demand for these two products, salt and insulin, is zero, or very, very close to zero. Now that makes us ask the question, why? And this is something that you need to really understand. Why is it that some things, when the price goes up, people buy a lot less? Price goes up a little, people respond a lot. They have a high elasticity. But other things, when the price goes up, people don't respond very much at all. They're very inelastic. So salt and insulin are two of the things that I think have the lowest elasticity possible, zero. And when something has an elasticity of zero, we call it perfectly inelastic. Perfectly inelastic. So let's write that down over here. So if, I'll just use the letter E like this for elasticity for short. If any elasticity is zero, doesn't matter if it's price elasticity or some other kind of elasticity. If the elasticity is equal to zero, we call it perfectly inelastic. Remember, elasticity means responsiveness, or elastic means responsive, and inelastic means unresponsive, and an elasticity of zero means you're perfectly unresponsive. Let's go back and look at the salt and insulin. So what would your prediction be if the price of salt goes up by 1%, or if the price of insulin goes up by 1%, what would happen to the quantity demanded? Well, let's use our little kind of shortcut formula here, right? We're looking at the ratio for the standard interpretation. What we want to do is take 1% and put it on the bottom of a fraction here and ask what percent change in the quantity would go on top to make that ratio equal zero. What divided by 1 equals 0? And the only answer is 0% goes on the top there. So how responsive are people if we can raise the price 1% and they don't buy any less? Well, they're totally unresponsive. And this kind of also implies we could raise the price by 10% or 50% or 100% and people wouldn't buy any less. Very interesting. What is it about salt or insulin that makes them perfectly inelastic? Well, for two different reasons. So let's start making a little list of reasons why things are elastic or inelastic. Salt is perfectly inelastic because it is so inexpensive, terribly inexpensive. You can go into a grocery store in the United States and you can buy a 1 pound can of salt for maybe 50 cents. And for most people, a 1 pound can of salt will last them years, unless you're a really, really big cook. A 1 pound can will last you a long, long time. So suppose the price doubled, right? Suppose the price went up by 100% for salt. Instead of 50 cents for a pound, the price went up to $1. That would be 100% change in the price. What would happen to the quantity demanded? Would you buy less? When company comes over to eat dinner, would you tell them, whoa, whoa, stop using so much salt. Don't you know the price went up? I don't think so. And it's because it's so cheap. Your amount of salt in your budget is so small, you don't notice it. And so you're not going to notice when the price doubles or even triples. It's not going to bother you that much, right? So one of our rules, one of the things you need to know to write down is that when it comes to price elasticity of demand, one thing that affects how responsive people are is how large of a share of your budget this good takes up. So if it's something extremely inexpensive like cotton balls or salt, when the price goes up, you're not going to notice it. You spend probably less than $1 a year on these kinds of items most of the time. What about insulin, though? Insulin is not all that cheap, but still, I would argue that the elasticity is going to be pretty close to zero. If you're a diabetic, you're going to have to take a certain amount of insulin, however much your doctor says to take. Now, what would you do if the price of your insulin went up? Are you going to use less? And what are you going to do if all of a sudden you can get your insulin more cheaply? Are you going to start using more insulin every day? I doubt it. I think you're probably going to be perfectly inelastic or totally unresponsive to the price, unless the price gets so high that you simply cannot afford it anymore. And then you'll have to use less, right? But at least within some reasonable range of prices, salt and insulin, people aren't going to respond very much. But this brings us to the second reason, the second thing that affects how elastic things are, how price elastic goods are, and that is, are there any good substitutes? Are there any good substitutes? So the idea here is, look, if the price of insulin goes up, it's not like you can switch to buying something else that's going to serve as the medicine you have to have. If you don't have it, you're going to die. Now, if there was a good substitute for insulin, I don't know, maybe bacon or maybe some other kind of drug like aspirin, if the price of insulin went up, maybe you just use aspirin instead, but that's just not going to work. There aren't any really good substitutes for insulin. So when the price goes up, even though it could be expensive, because you don't have a choice, there's nothing else you could buy instead, the fact that there aren't good substitutes means that you're not going to be very responsive. You just can't buy less insulin and then switch towards something else. As a totally different example, think about Coca-Cola versus Pepsi versus some other kinds of drinks. If we wanted to calculate the price elasticity of demand for Coca-Cola, well, if the price of Coca-Cola goes up, there are plenty of other things that you could drink. You don't have to drink Coca-Cola. You could buy Pepsi or some kind of store brand cola, or you could drink water or orange juice or tea. There's just so many other things you could buy instead. So we would expect that people be more responsive when the price of Coca-Cola goes up than they would to when the price of something like insulin goes up, where there aren't very good substitutes. Now, if something is perfectly inelastic, like we were talking about with salt and insulin, let's draw a demand curve over here on this supply and demand axis with quantity on the bottom and price on the y-axis here. What would a demand curve look like if it was perfectly inelastic? Well, it's going to look like this. It's going to be vertical. Now, why is it going to be vertical? Well, the reason is, if you look down here, what this is saying is the quantity that you demand, the quantity you're going to buy, is the same no matter what the price is. As the price goes up or the price goes down, you're going to buy four all the time. Perfectly inelastic would look like. All right, let's look at some things that are a little more elastic here than salt and insulin. Eggs. Now this is still pretty inelastic, 0.1. Now keep in mind, this is really negative 0.1, but don't forget there's this lazy habit of economists that we drop the negative sign pretty often when we're talking about price elasticity of demand. You just have to know that it's always negative or zero, right? So eggs, very inelastic, close to zero, but not quite zero. If the price went up by 1%, what would happen to the quantity? Well, let's use our little ratio technique over here. If the percent change in price was 1% on the bottom, what would have to go in the top here for the percent change in quantity if we were talking about eggs? What over 1 gives you negative 0.1? Well, the answer is negative 0.1%. So our answer would be negative 0.1%. So this tells us that if the price went up by 1%, people would buy a little less, 0.1% less, a tenth of 1%. What if we multiplied the bottom by 10 and we said, well, what if the price of eggs went up by 10%? Well, then we'd have to multiply the top by 10 as well. 0.1 times 10 is 1. So if the price of eggs went up 10%, we would expect people to buy 1% less. So pretty inelastic. Now why? Let's think about our two reasons that we've talked about so far about why things might be elastic or inelastic. What percent of the budget do you think eggs make up for most people? And here we're talking about in the United States, where most of these elasticities come from. Pretty small share of the budget. I mean, even if you bought a dozen eggs every week, for most people, that's not going to be a huge portion of your budget, right? But what about the substitutes issue? When we're talking about eggs, are there good substitutes? Like if you wanted eggs to put in a recipe or you wanted eggs for breakfast, are there really good substitutes for eggs? Nothing really great, especially if you're talking about a recipe. Now, there are things that you can buy in the grocery store that are called egg substitutes. But do you know what those egg substitutes, like egg beaters and things like that, are made of? They're made of eggs. They just take eggs and they take some of the fat or some of the cholesterol out. They're still eggs, but they've just been altered in some way. So they're really eggs, egg substitutes. Eggs, they're not all that expensive, and there aren't maybe a lot of great substitutes, so that's probably for both reasons why that's pretty inelastic. With something that's not perfectly inelastic, like insulin or salt, the demand curve, instead of being straight up and down, might be just a little slight slope to it, okay? Now, as we'll learn in the next video, slope and elasticity are not the same thing. They're related, but this curve here is still pretty inelastic. You can tell because even as the price goes way up to really high numbers, you're not decreasing your quantity a lot, okay? So pretty inelastic here. We've been talking about perfectly inelastic. We said eggs are inelastic. Let's go ahead and tackle the idea of at what point do we call something elastic or responsive? Any elasticity, if the absolute value, so when we talk about something being responsive or unresponsive, elastic or inelastic, we're not talking about the sign, we're just talking about does it move? Does it respond a lot? We're not talking about which direction does it move, positive or negative. So if the absolute value of an elasticity is bigger than 1, we call it elastic. And similarly, if the absolute value is less than 1, we call it inelastic. And if we have an elasticity that's exactly equal to 1, what do we call that? We call it unit, or sometimes people will call it unitary elastic. The word unit or unitary is just a fancy way of saying the word 1. So that's all unit elastic means, is the elasticity is 1. If you know any foreign languages, you might know that une in French is the number 1, and in Spanish, uno is the number 1, kind of related to the word unique, right? Unique, there's only 1. So unit or unitary elastic, fancy way of saying the elasticity is 1. Now, why put it in this way, greater than 1's elastic and less than 1's inelastic? Well, here's why. Because every elasticity is a ratio of a percent change Again, this triangle delta means change. It's a shorthand way of saying it, but it's a percent change in the effect on the top of a fraction divided by the percent change in a cause on the bottom. And what we're saying here is we're going to call something elastic if the effect is bigger than the cause. Well, that's going to make that ratio bigger than 1, and we're going to call that elastic, right? So, for example, if we had something where the effect was 12% and the cause was 6%, well, the effect was bigger than the cause. Let's call that elastic. Now, if the effect is equal to the cause, 6% on the top, effect, 6% cause, we're going to call that unit elastic, and that just means the cause and the effect are of the same magnitude, the same size percent change. And if the effect is smaller than the cause, again, everything's always measured in a percentage change, we're going to call that inelastic. So if we had something like 2% on the top divided by 6%, well, that's only a third, 0.33. That's going to be inelastic. And again, the sign doesn't matter when we call something elastic or inelastic. We're looking at how big this relationship is. How much bigger or smaller is the top than the bottom? So all of these elasticities here are inelastic. Salt, eggs, gasoline, up here through shoes. These are all less than 1. Now, we're not going to go through every single one of these, but let's hit a couple of these inelastic things just to make sure we understand why they're inelastic, and talk about a couple of other interesting things. How about gasoline? So gasoline here is inelastic in the short run. This means right after the price of gas goes up or down, how much do people react? How much do they respond with how much they buy? Very inelastic, 0.15 to 0.20 in the short run, immediately after the price change. However, if you give people 6 months or a year to adjust to this price change, the elasticity goes up considerably, but it's still inelastic. So let's talk about why is it inelastic in the first place. Well, it's inelastic in the first place. It's not because it's so cheap and it's such a small portion of most people's budget. I mean, it can actually take many people's monthly budgets. However, what about substitutes for gasoline? If you didn't want to buy gasoline, what else could you do? Well, in the short run, especially, there's not a whole lot of choice we have. We're working on it. Scientists are working on this issue. And there are some vehicles that are flex fuel, where instead of gasoline, you could put ethanol or something else in there. But there's not a whole lot of choice, not a whole lot of great substitutes for most people, especially in the short run. But what about the long run? What could you do differently in 6 months that you can't do tomorrow if the price of gas were to go way up? Well, there's a lot of things. I mean, number one, you could get a more efficient car so you could use less gas. You could get a battery-operated car or one of those flex fuel cars we were talking about in the long run, but you can't run out and do that tomorrow, or at least most people can't. So there are some things you can do in the long run to respond more than you can in the short run. You could also move closer to where you work, or you could get a job closer to where you live if you really needed to. So a lot of ways that you could economize or adjust, adapt, respond to a higher price of gas in the long run. So that brings up a third thing that we can add to our list here that are things that can affect the elasticity, the price elasticity of demand for a good. It's the length of time you give people to respond. The longer you give people to respond, the more they can respond, and so the more elastic they will be. One other interesting one here, where I have some short run and some long run estimates of elasticities, is for cigarettes. And we also have some elasticities for different kinds of people. So for adults, inelastic, less than 0.1 in the short run. So we would interpret this as for each 1% the price of cigarettes goes up, adults will smoke about 0.4% less. 10%, 4%, 100% change in the price, 40% decrease in the amount of smoking for adults in the short run. However, if you wait until after a price change and you look a year later, you'll see those same adults will be smoking a lot less if you give them longer to try to quit, right? Maybe find some substitutes these days with vaping and other sorts of substitutes that people have found for smoking. Now, teenagers are pretty elastic, well, still inelastic technically, right? Because that number is less than 1, but compared to adults, teens are much more elastic. Why? Why would teens respond more to a price change than adults would? Right. Cigarettes are going to be a much larger portion of most teens' budgets than they would of most adults. So this is one of the reasons why when we want, especially teenagers, to smoke less, one of the preferred policies is to add a tax onto those cigarettes. So here's an image from the Center on Budget and Policy Priorities that is a group that advocates for putting taxes on cigarettes. And here they're talking about this relationship. They're basically talking about an elasticity. And they're reporting a wide range of effects here because they're looking at a lot of different studies that have found different effects. And so they're saying here that a 10% increase in the price of a pack of cigarettes will lead to a 5 to 15, somewhere in that range, decrease in smoking among teens, kids under the age of 18, and a 3 to 7% decrease among adults. And if we run those numbers and we put, say, a 10% decrease in teen smoking divided by a 10% change in price, that's going to give us an elasticity of around 1, somewhere in the neighborhood of that 0.8 here, a little higher, but they give us a wide range with that 5 to 15% response. And with adults, 3 to 7%, if we take that midpoint between 3 and 7%, that'd be around 5%. They're suggesting an elasticity of 5% change in quantity on the top divided by 10% change in price on the bottom, an elasticity of about negative 0.5, which is what we have here, about 0.4 or about 0.5. Different studies are going to find numbers that are a little bit different, depending on what year they collect the data and exactly where it is that they're collecting their data for these price changes and responses of people. So here we have shoes getting a little more elastic as we go down the list here. 0.9, really negative 0.9, right? So what would we predict here? If the elasticity is 0.9 for shoes, if the price goes up 10%, what would we predict would happen to the quantity? We put that 10% on the bottom as our percent change in price. And what divided by 10 is going to give us 0.9, right? We can just solve that for x equals 0.9. And what we're going to come up with is that 9 divided by 10 is going to give us 0.9 for that elasticity. So you raise the price of shoes 10%, people will buy about 9% fewer pairs of shoes. That's getting close to that unit elasticity, almost an elasticity of 1, not exactly equal, but pretty close. Now let's look at a couple of these things here that are elastic. Traveling on airlines, traveling to foreign countries, personalized license plates, eating out, electricity in the long run, although our textbook suggests that the price elasticity of demand for electricity is only 0.13. The number they're talking about is in the short run. If your electricity price per unit of electricity goes up, tomorrow you're probably not going to react very much. You might not even notice that they've raised the per unit, per kilowatt hour rate for electricity on you for a while. And there's not a lot you can do about it. Yes, you can adjust your thermostat and you can start turning off lights, but in many homes, the thing that uses the most electricity is going to be electric heat and an electric water heater. And there's not a whole lot you can do about that in the short run. But if your price per kilowatt hour for electricity stays high for a long time, what a lot of people will do is they'll switch to a substitute. They'll get gas heat or solar heat or a solar hot water heater or a natural gas or propane hot water heater. So there are some substitutes. It's just they take a while for you to be able to get access to them and get them set up in your household. So electricity, much more elastic in the long run than in the short run. But what about some of these other things? Why are they elastic? Travel, flying, going to foreign countries. Well, they're pretty expensive for most people. Pretty big share of your budget to go flying or go to a foreign country. And also, there are good substitutes to going to a foreign country, and that's not going to a foreign country. I mean, very few people really have to. If you want to go on vacation, there are lots of places you can go on vacation that are a little closer by. So you don't have to fly. You don't have to travel to a foreign country. You could just do a staycation, as some people have been talking about recently. How about fancy silverware in China? Extremely expensive. And there are a lot of good substitutes. I mean, paper plates, there are cheaper plates that you can get at other stores that aren't going to cost you $50 or $100 per plate, right? Let's look at this fancy silverware in China, elasticity of 8.8. What would happen? What is our prediction going to be if the price goes up 1%? What percent is the quantity demanded going to decrease by if the elasticity is 8.8? If you said it's going to go down by 8.8%, you're right. And this is extremely price elastic. Price elasticity of demand, very high, very responsive. When the price goes up, people buy a lot less because there are a lot of other options. You don't have to eat on this fancy stuff, right? So as demand gets more and more and more elastic, the slope of the demand curve, again, slope is not the same thing as elasticity, but they are related, and we'll talk about that a little bit more in our next lecture. But as the demand curve gets flatter and flatter and flatter, usually that's more elastic. Now, why? Well, if we look at 2 points on this demand curve, at this point here, it looks like the price is $10. At this point over here, the price has gone up to about $12. Okay? So, medium-sized increase in price, but look at what happens to the quantity down here. Quantity went from 9 down to 5, so price goes up about 20%, $10 to $12, and your quantity almost gets cut in half, about 50%. So the response, the effect, is much larger than the cause when you look at it in percentage terms. There is the idea that theoretically we might have something where the elasticity, absolute value of an elasticity, could be infinite or be such a large number that it's practically infinite. Now, if that were the case, we would call that kind of thing perfectly elastic. Perfectly elastic, theoretically, is kind of looking like this idea. We've got the percent change in the quantity demanded, although it could be a different kind of elasticity we're looking at, but we're focusing on price elasticity of demand here. So the idea here would be that for a tiny, tiny, tiny change in price, maybe 0.00000, maybe we raise the price just so small, such a small percent that people shouldn't really notice. What people do is they stop buying altogether, right? So they cut their purchases by 100%, or they go, basically they stop buying because the price goes up a teeny weeny bit. When might this make sense? Well, the only case I can think where something like this might make sense is if you had a case where you had two goods that were perfect substitutes for each other, perfectly inelastic. You have such a good substitute that they're perfect substitutes. Now, what that means is that you don't care which of these two things you have. Maybe perfect substitutes might be orange juice, freshly squeezed orange juice from one company compared to freshly squeezed orange juice from another company, and the two orange juices are exactly identical. And they both sell for $2 a carton. What would people do if one of these two brands raised their price from $2 per carton to $2.01 per carton? Well, as long as the other company was still selling them for $2, the company that raised their price a tiny bit would lose 100% of their sales, right? Theoretically, yeah, you could have a case where the elasticity was infinitely responsive. You raise your price just a tiny bit, and all your customers will leave you. In practical cases, that's probably not too likely, but we could imagine that that could happen. In our next video, we're going to look at these other common elasticities here. Once we understand the idea of price elasticity of demand, these others are pretty simple. Income elasticity of demand, price elasticity of supply, and cross-price elasticity of demand we'll cover in our next lecture. If you have any questions, as always, please let me know. Otherwise, good luck in all your studies. I'll see you next time.